Can you hear me? Can you see the screen?
Yes, sir. Yeah.
The blocks are released at t equal to 0.
So I've sent the question before this, like the one, the actual question, the main question. Sorry, you have to rotate it. Yeah.
Okay. Two blocks A and B on a horizontal frictionless surface. Okay, the blocks are joined together by a spring. Okay. Block A has a mass 4 kg and block B has 6 kg. Variation of tension F with extension X of the spring is shown in figure 2.2. This is not complete now, I think.
Should I send the graph too?
Variation of tension F with extension X of the string is it a
Should I?
straight line?
Wait. Wait. I'll send the question. It's a straight line, yeah, from the gradient.
Straight line. Okay.
It's a straight line from the gradient.
Okay, so force is increasing, extension is also increasing. Okay, that is obvious also. The blocks are released at t equal to 0. On figure 2.3, sketch a graph to show how the momentum of block A varies with time t until the extension of the spring becomes 0. In figure 2.3, time versus momentum is given. So with the time, momentum is increasing.
Yeah, the momentum should increase, right? But in the mark scheme, the answer is the down one, the one I've drawn below. That's, I mean, that's not shown. It says, the mark scheme says, uh, wait,
This you have drawn, na?
the upper, no, both of them are drawn by me. The upper one was before checking, and then after checking, I drew the bottom one. Yeah, the answer is curve starts from origin and has a decreasing gradient. Final gradient of the graph is 0.
Force increases, extension also increases.
Shouldn't it have an increasing gradient? Because acceleration will increase, right? So momentum will also increase.
So we are applying the, we are extending, we are stretching it. Okay, so as we are stretching it, tension is increasing. Okay, so and it's a straight line given to us. Okay. So what will happen then? Okay, this is the block here. This is the spring, and now we are stretching it. Another block here. Okay, so as x is increasing, the force is also increasing. It's a frictionless surface. Frictionless surface. So friction is not there. Friction is not there. Here. Friction is not there, then how it will happen? What they have given in marking scheme?
Yeah, they said curve starts from the origin and has a decreasing gradient. Final gradient of the graph line is zero. Like different sentences. One mark for curve starts from origin and has decreasing gradient, and one mark, the final gradient of the graph line is zero.
So it's
So
like
if you look at the second drawing, which I have made, is that the case?
this, like draw like this, and that something like this.
Yeah, I'll get one mark for that. And then it goes down. Final gradient should be zero, right? Oh, it becomes steep.
Zero,
Oh, it becomes flat.
zero
Oh,
gradient.
it becomes flat.
Ah,
All right, yeah.
this is not
Oh, okay. So, but
horizontal.
then why?
Ah,
So how though? How is it possible? It's a frictionless surface,
question
and the
not
moment.
here. It's how it is happening. है ना? Is somebody pulling the block? How they are pulling it? है ना? Somebody is pulling that block. Okay. So if you pull that block, there is no frictional force. Then both the blocks will move together. Okay. Okay. Both the blocks will move together.
Yeah.
Okay, I will think about it. Okay, let's move some other topic. So I will have to think about it. Okay.
The next question.
Ah. Alishba, do you have any doubt? Alishba,
So it's in the why do we use the formulas? That's it.
could not understand. Please repeat.
It's in using certain formulas.
Which formulas?
The double slit experiment formula.
Okay. So
The
see the
lambda is equal to ax upon d.
so see the formulas and meaning of each term. Okay, and also all the terms have to be converted to SI units. Okay. The questions do come from that, what you are telling me, you know, that.
So I saw questions from this one.
Are you able to
Uh,
solve?
gratification thingy, d sine theta is equal to n lambda.
Ah,
I
so,
didn't see from Moll's law or double slit experiment.
ah,
So if you can just explain a bit of double slit experiment and like what's the Moll's law, so like I know where to use it and where to apply it.
okay, okay. Hmm. Double slit and Malus law. Huh? Okay, in this, what is your doubt, Hardik? Yeah.
So I've sent another the actual question. Yeah, I want to know if what the right graph will look like. The second graph. I got the first one right. The graph of the acceleration A of the ball is that's correct, but then the B is wrong. Second one.
So see the question. A ball is projected with horizontal velocity 1.1 meter per second from a point A at the edge of a table as shown in the figure. Okay. Ball is falling like this. Okay. The horizontal velocity remains constant, but there is acceleration in the downward direction. So there will be another component of velocity that will come into put. Okay, so this will remain 1.1 and then this velocity keep on increasing because of acceleration in the downward direction. Okay. So what is the question now? The ball leaves the table at t equal to 0 for the motion of the ball between A and B. Sketch graphs to show variation of with time, acceleration A of the ball. So yes, acceleration is only in the downward direction and it is acceleration due to gravity constant, so it's a straight line. This is correct. It's correct and it's a correct straight line. Next, the vertical component SV of the displacement of the ball from A. Vertical component SV of displacement of the ball from A. Displacement of
Shouldn't
the
it be
ball
like a
is from
constant acceleration? So
displacement of the ball is from where? From A to here, na? B. So they are asking about the horizontal pattern. Okay. Vertical component of displacement of the ball from A. Vertical component of displacement. The vertical component of displacement means this, na? This they are asking. Okay, this part they are asking about. Okay, so what is happening as the ball is falling down, its velocity keep on increasing with the time. So it will be covering more distance as the time increases. Okay, so it will not be a straight line. Okay, it will not be a straight line, so it will be rather a curved line, something like this, which is increases with the time. Okay, so but yes, it is. Yeah, yeah, yeah. Which increases with the time. Okay, so it will be something like this, some curved graph like this. Are you getting this? Because
increasing
the
gradient.
because velocity is increasing because there is acceleration equal to g. Okay, so it's a displacement time graph. If I take the gradient of it, I get the velocity. So see, if I take the gradient of it, gradient is increasing with the time. Okay, so this graph will look
Wait, so but then isn't acceleration constant?
acceleration is
Like,
constant. Yes,
yeah. So how will
but
velocity, the change in velocity be different?
this is the displacement time graph, not velocity time graph. Velocity time graph will
All right, all right. Oh, it's a displacement. Oh, right, right. Sorry, I thought it was all
velocity
right.
time graph will
Got it.
look like this. है ना? Velocity time graph. है ना?
Oh, all right. So it's a silly
It will
mistake.
be a
Wow.
straight line. It will be a straight line like this. Oh, sorry. It will be a straight line like this. Okay. It will be a straight
Yeah.
line. Alish Bar, you are getting this thing? Such questions you can
Yes,
expect.
sir.
Ah. First questions you can expect tomorrow.
Sir, like I I just have a doubt. Is it like, are there certain graphs where you will have a curved gradient, or like any graph can have a curved gradient or a curved line?
Depend on the situation. Okay, depending on the
So like
situation.
even a velocity time graph can have a curved line.
Yes, it can have. Suppose it's a velocity time graph. Okay, so tell me if it's a straight line, what does it represent?
It's constant.
What is constant?
Accelerating with
Uh, acceleration
acceleration
is
is constant.
constant. Okay, acceleration is constant. Okay, but say when you are taking the say air friction or something like that. Okay, suppose some object is falling down. So some object is falling down, then what is happening? This weight remains the same, m into g.
Yeah.
But as it comes down, the velocity increases, and so does the drag force. Okay, drag force increases. So what will happen? Its acceleration will keep on decreasing. Okay, this acceleration will keep on decreasing till it attains the terminal velocity. Okay, so its graph will now no more look like a straight line. Its graph will be like this.
Constant, yeah.
A
Graph will be
curved
something
line
like this,
with decreasing gradient.
like this. And this is the point of terminal velocity when it is a parallel line. So its slope is zero. Slope zero means what? Acceleration
So
has
won't the line be from up to down?
no, because we have to see the gradient of this curve. And if I see the
Oh,
gradient of this curve, if I find out the gradient at this point. So how is the gradient? The gradient is like this. And when I'm going here, the gradient is like this. Okay. At that type point, the gradient is like this. So the angle is decreasing. So if the angle is decreasing, tan theta is also decreasing. Okay. And tan theta is nothing but the value of this acceleration. Okay. All right. So other way around also can happen. They can give some different type of a force where the force is increasing with the time. Okay. So in that case, the it can happen that the curve will look something like this. And if the force increases with the time. Okay. So like the acceleration is increasing with the time. Okay. This shows acceleration is decreasing with the time if it's a velocity time graph. And if the curve is like this shows acceleration is increasing with the time. Say for example, we have a force which increases with the time. Suppose there is a block is there and we are pulling it with certain force. The force is not constant, but it is increasing with the time. Okay. So then it will no more be a straight line. All right. So
Yeah.
let us discuss one more.
sir, I'm so scared for tomorrow's exam. You have no idea.
Don't be scared, just give your best and whatever you can. Okay. I will also try to come okay tomorrow morning. Although I will not be
So
invigilating.
when will you be coming?
My invigilation is at 1 p.m. है ना? But since your exam is there, so I am thinking of coming tomorrow. Okay.
So
In,
I'll come early if you want, but then because
yes.
I will probably have some doubts. I'll be solving a lot of papers at night.
Now no more doubts. Okay.
So after this one more paper. So I haven't solved the specimen paper and the latest paper. So if when I solve that, I might have some doubts.
Okay. So in this
When will
question,
you be coming then?
Sir, I'm just solving the 2019 paper, so I'm scared that I might miss out like what's there in the other papers. I don't know what to do.
you don't have to be scared. And if you know the theory, you have practiced different types of questions, so most
So, but
probably
then
you'll be able to
no
do.
matter how many questions you practice, it's never enough. So like
Yeah.
I'm
But
a bit scared.
but if the understanding is there, any type of question you can solve. Okay. So in this question, what is your doubt, Hardik?
So I've sent another image. Can you just open that?
Okay, okay,
So this was there in the third mock.
okay. I have given this question.
Yeah, it was there. But then I don't know if this is the right working because the answer in the mark scheme is 1.5 times 10 to the power of 4, and my answer is 1.4. In the mark scheme is 1.5.
Yes, sir, this is a big doubt. Okay, sir, sometimes they round off the actual answer like 934 to 900. And in the marking scheme, it's only 900 given. So, like, how do I know when to round it off and when to not round it off?
Round it off
And
to two
sometimes they don't.
significant figures, है ना? Two
But, sir,
significant.
sometimes they don't round it off. And in the marking scheme, there's only one answer. They don't write it as 934 or like 900. Only 900 is
Actually,
there.
there's but there's actually the standardizing mark scheme, like which is before the mark scheme is made, and there are lots of exceptions in that. So I think that you'll be fine if you don't get, because the final mark scheme which you see on the internet is
Yeah.
like the final after like the examiners have
Oh,
discussion and
yeah,
stuff.
yeah, yeah, yeah,
There's a
yeah,
lot
yeah.
of exceptions.
So this question is: a leisure park ride consists of carriage moves along the rail track. Part of the track lies in a vertical plane, follows an arc of a circle radius 13 meter. Okay. Mass of the carriage is at point X, carriage has a velocity 22 meter per second in a horizontal direction. The velocity of the carriage then reaches 12 meter per second in a vertical direction at point Y. Okay. So initially the velocity is along this direction. Okay. So this is the velocity. So momentum along this I can write it as Px. Okay. Px is equal to what? 22 meters per second. This is the velocity and I
Yeah,
have to multiply it with the mass. Mass is how much? Mass is not given. Mass is given 580.
580.
So 22 into 580. Do that. How much?
I'll do it. Wait.
22 into 580. Yeah?
It's 1,207.60.
1760.
12760.
Kg meter per second square. Now when it is reaching this point, what is happening? Its velocity is this direction and so does the momentum. The momentum is
So what,
P1.
what?
Velocity is in the upward direction and so the momentum is also,
Yeah, yeah.
mass is 580 and velocity has reduced. It has become 12. So 580 into 12. Okay. 580 into 12 is how much? 580 into 12. 6960. 6960. Okay. Kg meter per second square. Okay.
So, but then the direction is different, right?
Yeah, direction is different. So what they are asking in the question, determine magnitude of the change in the linear momentum when the carriage moves from X to the Y. Okay.
The voice is lagging. Can you repeat that?
Magnitude of change in the momentum when the carriage moves from X to Y. Wait. Magnitude of the change in linear momentum when carriage moves from X to the Y. Linear momentum initially is in the X direction and then in the Y direction. Okay. So something about vectors, and I think that has not been taught to you, vectors. Okay. So this is related with the
I know vectors,
uh,
the triangles, right?
something about so initial momentum, say P1 is how much? I'm getting how much? I'm getting 12760. 12760. 12760. And this is in the X direction. So let me denote it by I cap. I cap is the unit vector in the x direction, okay, and in the y direction initial momentum is 0, so I can write it as 0 j cap,
J cap.
okay, and then the final momentum p2 is, see here, 696.
So how do we do it like that? We don't know. We don't know vectors, right?
6960. So along the x it is 0, but along the y it is 6960 j cap, okay.
So what is this?
This is a little bit about vectors, okay. So see here, initially this velocity is along the this momentum is along the x, okay. Along the y there is no component, so I write in vectors like this. This you read in your mathematics, okay. So this is the x component, so we represent it by some unit vector along the x-axis. There along the x-axis is the x-axis, and this is the y-axis, this is the z-axis, okay, perpendicular to this, okay. So initially it has only x component, no y component, so I'm taking it as 0. But finally the what is happening, it has only y component and the x component is 0, okay. So now the change in the momentum will be nothing but I will have to subtract it, okay. So I will get p2 minus p1, p2 minus p1. So when I subtract it, what will happen, it will be 0 minus 12760, so it will be minus 12760 I cap, okay. Similarly, I will subtract the y components also. So it will be 6960 minus 0. So it will be 6960 j cap. Okay. So this you are getting the change in momentum, okay, in the vector form, but they are asking us the magnitude. So suppose you have any vector like this, say any vector x equal to given as say a I cap plus b j cap, okay. So if I have to find out the magnitude of the vector, so magnitude of the vector I represent like this, mod of x. So that is given by under root of a square plus b square, okay. It is given like this. So this is what you have to find out. So the magnitude of this momentum will be delta p, and I will put it in the mod sign. So this will be equal to under root of square of this and a minus 1.12760, square it. So even it is a minus, it will get positive, okay. So this square plus this square, you find out this value, it will come out same as what is given in the marking scheme, okay. Try to find out this value, how much it is.
Yeah, it's 14534.
So you can round it off to say 1.5 or what is something, okay, into 10
1.5 times 10 to the power of 4.
Yeah.
So is my working wrong?
Yes, this doesn't seems correct, okay. How you are taking 45 degrees? The angle is
So
changing by
I
9.
don't remember how I did it.
See, this is angle change is 90 degrees. How you are taking 45? Okay, so this is
So
the
it's
correct way.
90.
This is the correct way of doing, okay.
So but then we aren't taught this. Like, so how are we supposed to know?
So this you will read in the mathematics vector chapter, okay.
So I don't have mathematics.
Then you have to do some extra reading, this is, and this is not very difficult, okay.
I know. I feel like I've done this.
Alisha, are you getting this?
No, sir.
Not getting?
No, sir. Vectors. No.
So can you try making sense like in something else other than the vectors? Because in the mark scheme they did this. That part where you square rooted the 12760 square and plus 6960 square. That was there in the mark scheme.
Okay, so what you do now, that's see, initially it is in the x direction, this one, hai na? And finally it is in the y direction. So what you do, you just take under root of px square plus py square, okay.
That's like Pythagoras.
Pythagoras theorem you do like this. Okay. So this you understand, px square plus py square. So that is what we are doing. Okay. So you will get that answer.
Okay.
Okay.
Sir, but sir, can you go up? Sir, how 22 into 580? Can you go up?
22.
No, sir, like the one that you solved right now. Can you just show that? Yeah. So
Mass
Py
into
is equal to
velocity.
5. If 580 into 12 gives you 6,960, and the same thing gives you 12,760.
580 multiplied by velocity. Velocity is changing.
Okay, 22.
Infinite
Okay,
per
I saw it as 12. Yeah.
Okay. Now before we proceed to next, let Alisha have some doubts that young slit.
So like I know what to use when, like the what the A stands for and everything, but then like a basic knowledge about the experiment would be nice. And so do we need to know all the type of quarks?
Quarks, you just try to remember. Okay, I think it's not. It will be usually the last question, 5-6 marks. Okay. So this is the Young's double slit experiment. Okay. Yeah. So this is the relation, hai na? Lambda is equal to ax upon d. Lambda is the wavelength of the light that you are using. Okay. D is the distance between the slit and the screen. A is the slit width. Okay. A is the slit width. Okay. And x is what? X is the separation between the adjacent.
Distance between fringes.
Like between any two bright, like this, between this bright and this bright. So from A to C, this is the x. This is called as fringe width. Okay. This is called as fringe width. So this is important. Okay. Questions may come on this. Okay.
Answer at the now.
So see some questions
So
and
I'm
some past
scared for
photo.
polarization. So I looked so hard for polarization questions, I couldn't find any. I think that's what she means by Malice law, right? The polarization.
I think so. Yeah, I think so.
Is there like something, some plate through which a line passes and then it tilts?
I don't know, but then
Is it this?
This is the Mallet law.
So why did they add this?
so I
What's the
learned only
point?
two things from this. Vibrations are restricted to one direction only,
Okay.
and there's one.
So this is the unpolarized light. Okay. When we are passing it to some slit, okay, vertical slit. So vibrations along all the other direction stops, ceases, but only where the spacing is there and it will only pass through it. So it like it is going just up and down. Okay, vibrations are only in the up and down direction. So we can say that the light is polarized. So to do that, they pass it through some material called as Polaroid, okay, or polarizing filter. Okay. So like this here, this is the unpolarized light. I'm passing it through some Polaroid. Okay. So this Polaroid has some transmission axis. Okay. So along this, after passing through this, all the vibrations will get stopped only. It will have a vibration in the up and down like this. Okay. Now, suppose if you have two Polaroids, okay, so one is this left one and another is another polarizer. Okay. So what is happening? Suppose when both of the axes are vertical, so what will happen? Nothing will happen. Okay, they will pass as it is. Okay. Whatever it is passing from the first polarizer, second polarizer, same thing will happen. Nothing is going to change. Neither the intensity nor the amplitude. Okay. And intensity is what? Intensity directly proportional to the square of the amplitude. Okay. But what happens when we rotate this analyzer by certain angle? Suppose we are rotating it like this, perpendicular 90 degrees. So what will happen in that case? No light will be transmitted. Okay. But if we are rotating it with certain angle, say theta, Okay, certain angle say theta if you are rotating. Okay. Okay, so like this is already
So, like,
a
give an example how might the questions come. Like, I have an idea of like other stuff, like how an question can come from, but for this thing, I don't know how will the question come.
see. So this is what kind of a light. It is also polarized light. Okay, it has only vibration in one direction, isn't it? But it is inclined at certain angle, some angle. Okay, and its intensity is I naught. Okay, so what is happening? It is again passing through another polaroid. Okay, so this polaroid will allow the vibration only along this vertical. Okay, so what will happen? Only a component of this is going to pass through this. Okay, a component of it is going to pass through this. That is, suppose this is the a naught here. So a component of it, that is a naught cos theta, will be able to pass through this. You know the resolution of vectors, है ना? So a naught cos theta will only be able to pass through this. So what will happen in terms of intensity? We know that intensity is directly proportional to square of the amplitude. Okay, intensity is directly proportional to square of the amplitude. So what will happen here?
So the cos theta
Ah,
gets squared too.
yeah, so the intensity, initial intensity was I naught. So I naught was kind of directly proportional to the A naught a square. Okay, but after passing through this, now instead of I naught we have I, and that is directly proportional to what? A naught cos theta. Okay, and it's square kind of. Okay, it's a square. Okay, so that's how they are relating this. Okay, they are relating this something like this. Okay, so this A naught a square, we can replace it with some I naught. Okay, so that is from there this formula is coming. I is equal to I naught cos square theta, where I naught is the intensity before it passes through the another polaroid, and theta is the angle between the this polarized light and the transmission axis. Okay, so if you see about the question, I will again renew the meeting in 5 minutes. You can take a break for 5 minutes because this meeting will end in less than 1 minute. Okay, so after this we will